Doing videos and JPEGs and things and fragmented content again. Now, this guy's been around for a long time. He's from England or something. I've met him. He's a bell ringer. He goes to all the bell towers in the entire world and rings the bells. And so I met him when he came to Marietta in Georgia. And so we sat down, had dinner, and did whatever. He writes forensic software, and he is one of the only guys that has been able to rebuild Sony cameras. So the videos that come off of Sony cameras and some of the other stuff. So he focuses some on the recovery of video files and types of video files and reassemble. And if they can't be completely reassembled, he has a way of rebuilding the chunk that's good and at least giving you back that piece of it. So this is another one of those tools, not super expensive, that I don't even remember how much it costs at this point. A couple $100 was what it was when I first bought the full license for everything, forensics features. Yeah, $159. So if you're going to do anything with cameras and other video, this would be the one thing you want to do. And then if you do security systems, I think it's DME.
Forensics?
Yeah. If you're doing any security systems, you can rebuild things with the codec by hand yourself. It is very extensive and takes a really long time to do it. And so DME makes a forensics tool that rebuilds the entire structure, time code, and everything from all the videos from security servers, security systems. And it is very good. I was very, very impressed. I own this. It is $4,000. Right? $4,000. But it can rebuild the security systems. I don't know if they'll give us a good picture here.
It's worth it.
It is worth it. And when it comes to dealing with the security systems and anything that was fried, burnt, has all those videos on it, super difficult to hunt everything down to rebuild, get the structure back. And so they do sell like a one-off version. You can work on one single case for like $1,200 or $1,000. So if you have a case that would pay you $8,000, it's worth doing the $1,000. However, the one problem with it is it keys to the drive and makes a hash. And if the hash changes, it no longer works. So if you have a problem and you're doing a recovery, I had to re-image a drive, then I cannot get access to that file again. So if I fix a couple of sectors, it no longer has the same hash, even one sector, and now I can't use it. So the $4,000 version doesn't have that problem. You just use it on whatever you want to use it on, and then there's a yearly renewal license. So if you're...
They make you want to buy the $4,000 version.
Yeah, but I mean, it's nice that they have an option that you can buy it for $1,000. Like, because I was able to convince a client that, listen, this is a special thing. This isn't the kind of thing we normally do every day. And I got them to pay the $1,000. We did everything we could do. Then they wanted to do more. So then I got them to pay the $4,000. So you can, I mean, you know, at least I had an option for getting it started and getting something going to show that we could get a big portion of this. Because these are drives that were in fires. They were burnt, and it was something from an insurance company, and they had to prove who did what. And so then there was some big money involved. But, you know, even when there's big money involved and they're making $100,000, if you say, I'm $10,000, they still won't give you the job. So you got to show it with something that's more affordable. Anyway, we got it done. These are the ones that I would use primarily if I'm looking for something. So I just want to give you the breadth of the main things I run into. I didn't show UFS Explorer, but anything else that the other tools don't do, the two tools that can do anything nobody else can do is Reclaim Me Pro and UFS Explorer. So, and then everybody else is like an add-on for videos and all the other stuff. UFS Explorer also has, now in version 7, also controls a deep spar. So they also have functions built in now after version 7 to control deep spar and do your recovery directly through the deep spar. So now you have those options for their tool. Not super expensive. I think it was like $300, but the products that you want, like the UFS Explorer Professional, it will process all kinds of things, file systems that you won't get in other places. Tries to do so these things with encryption. This is alternative to Encase, because Encase was the only place we could go to get a box to pop up if we were in data recovery versions trying to get the encryption codes. You have to know the passwords. This is not cracking your encryption. You have to know what the encryption keys are, so somebody's got to give you the passphrases for BitLocker or Apple File Vault or any of your encrypted OSs. You have to have the key to get in, but they pop up the box and let you open it with the key. Does that make sense? Our Studios only has APFS. I haven't seen one for anything else in there. So at least from that standpoint, you do have quite a large quantity of things that this tool can do. And so if I have to fall back to anything automatic that I can't do by hand, it is worth the $300. I'll make my money back in a day. And like I said, it's in euros or pounds or something. And they used to have plugins too. You could get plugins or work on plugins. So with every single thing, even in a corporate license, I mean, that is not expensive as a whole. I mean, by the time you're done, it roughly is $300 or whatever it is. So with everything, that's the standard. There's a pro version. I thought the pro version was $299 or something. No, they've upped their price. Maybe they added forensics in there. So
the upward.
Yep. Anyway, so but again, it's a fantastic package. It's been one of the best packages again for doing a lot of stuff nobody else can do. All right. So now back to our other normal life. Except for that one last thing was Directory Opus. I don't know if any of you looked that up. Directory Opus is I don't even know how much it costs anymore.
Like,
I'm using 12, but I just keep updating, so I keep paying the update fee. How much is it?
it's like 89.
Yeah, 89. It's 89 Australian, which is 30% below our money. So right now it's going to be like 59 bucks or whatever it is. So that's 30%. So
They have bulk licenses to the left.
yeah, they do. And like, because when I ordered them, I ordered like a huge pile of them. Where is it? Volume licenses? Is that where it is? And when I ordered a huge pile of them, by the time I got to a spot, it actually becomes like almost nothing. Like there's like a spot where once you buy a certain quantity of them, and I was only at like $500, and I was able to get like I own 25 or 35 copies, so I'm somewhere in here, and it wasn't that expensive. I spent less than I spent $500 at the time, so I don't know what the number is with them. Huh?
It's 20 bucks.
Anyway, just or buy one and make a thumb drive out of it or something. But it's well worth it to me from that standpoint. Those are the best things that I've had. Now, all the tools that I use in data recovery, I made spreadsheets for, with descriptions and the age of the amount that you pay is aged at this point. But I wrote 21 pages of software and hardware tools. And so when I give this out, you'll find 2 spreadsheets that are on here that are 12 pages each or 10 pages each or something. And it includes lists of all of the tools and what they do and column and where the link is where you can go get them. So that way, free and cost. So based on those things. I try to use things less expensive. But the really cool thing about data recovery is, as you saw, the list of the highest thing might have been $8.99 or $9.99 in the whatever that would have converted to. Yeah, compared to 5,000. And once you have one, you don't need to update every year. I mean, I'm really big about not even trying to update till it has something I need in it. So I won't update very often. And if I do, I usually leave that version on the machine, get a new machine, and the new version goes on there so that I can fall back to the old version when something's missing or something doesn't happen. And I promise you, every version, something disappears, something bug crops up, and something that you used to do worked fine. And you're the only person apparently that ever did it. That's what happens to me. And so, all right, so back into this. All right, so next, I'm not going to spend, I'm going to skip this part with the long file names. This is all about FAT 64. We already had a brief discussion about FAT 64. It was created for Windows CE in 2006. They thought it was going to be, they literally had a party for it. I'm not kidding. And no one came. So they had a party because as soon they were going to release this. It was told in 2006 it was coming in the next version of the Windows Phone, and then the iPhone came out, and their sales plummeted like a rock, and so they couldn't find anything to use it for. Windows CE was used in some things at like movie theaters for you to pay for your ticket, and one gaming system, and the rest of it wasn't used at all. Nobody did anything with it until 2009 rolls around. In 2009, what happened is Microsoft is one of the main organizations involved in the SD card association and the creation of the SD card. All SD cards at that time were all SDHC cards. So those HC cards are all FAT32. The largest you can format FAT32 is, in a Windows system, 32 gigs. So at that point in time, we finally started to exceed 32 gigs. 2006, 2007, we roll around 2009, and all the camera manufacturers are squealing because they can't use the cards. They had to pay a license fee to Microsoft to use SDHC. SDHC cards are licensed. Every single thing is patented, encumbered, and licensed. The manufacturer who formats the card, the manufacturer who manufactures the card, the system it goes in, the card reader, has to pay a licensing fee. So the reader that goes into your machine pays a licensing fee to read SDHC. And then the driver that goes on your computer to read it also pays a licensing fee. I'm not kidding. There's a licensing fee for every single thing. So when finally they said, let's get past 32 gigs. How are we going to get past 32 gigs? Microsoft raises their hand and says, hey, you know what? We wrote this thing called ExFAT. And we ain't been able to use this for years. So we really need to, and they didn't tell them that obviously, but they're like, we need to use this on your new cards. So they made a new card, and it's called SDXC. So that's where the X came from, is ExFAT. Okay? Do you know where the X really comes from? Anybody know why it's called? They give you a different description every single time, but John St. James or something, the guy who used to work at Microsoft, told everybody what it really was. Nobody know?
Extortion.
Huh?
It's an extortion.
Extortion, yeah. XP. Why is it called XP? Remember, XP was never supposed to exist. It was all supposed to be built into Windows 2000. There was never supposed to be an XP. XP was an afterthought. It was an add-on to Windows 2000. And then when 2000 died, because it became Windows 2000 Workstation, and only businesses used it. But you know who didn't use it? What? Gamers. Gamers, that was the whole reason that XP existed. Was XP, they could not get DirectX drivers working in Windows 2000. So when they released Windows 2000, it was not a gamer's platform. It was a workstation platform because it didn't have any of the tools to talk to the hardware. So DirectX was created for Windows 95. Windows 95 was the first operating system that allowed a full-fledged GUI operating system to poke a hole through the operating system and talk to the hardware. So if you were a game writer before 1995, you had to write the driver for your video. And that meant if somebody had a monster video card, you had to write a driver for the monster video card for your game. If somebody had a 3D graphics diamond card, they had to write a driver for that one. You can only play games on certain video cards. You couldn't play them on anything else. So Microsoft says, well, why don't we create a GUI operating system and we'll allow you to play games in a window. Well, what do you have to do that? So John Carmack, you know who John Carmack is? He was a big proponent of OpenGL. And OpenGL would have worked across any platform. Technically, that's kind of how a Mac works for games and things like that. He's a big proponent of it. Microsoft came over and he wrote Doom, Quake, Wolfenstein, all the stuff. Like, he's the guy who created 3D first-person shooters as we know them. And so he's a multi-billionaire at this point. Anyway, so Microsoft comes over and hands him a stack of cash. I'm not kidding. Literally hands him a stack of cash and says, listen, I know you like OpenGL. Screw OpenGL. DirectX. Here's some money. I want to hear DirectX come out of your mouth. That's what he did. On the night that Windows 95 was released, he had written a version of Doom that would run in a window. That was the whole deal. That is the first game full-fledged 3D, not Minesweeper and, you know, whatever, tic-tac-toe or something else. Like, he literally wrote a version that would run a full 3D in a window, DirectX out through the hardware. So DirectX was the way it was all going to go. Windows 2000 is a completely different platform. It is not the same as Windows 95. Windows 95 belongs to the editions of Windows 95, Windows 95 SR2, Windows 98, Windows Millennium. Those three have the same memory model. They're a flat memory model. They sit on top of a DOS-based memory model inside of Windows, which uses an extended memory model to get more memory out of 640. You only have 640K. Everything else is then paged because of a bug. It's literally a bug. If you address right before 1 meg of memory, 1 meg of memory, you can get into the next portion of memory because addressing 64K over it breaks a barrier on the boundary. And so you're over 1024. Does that make sense to everybody? So it's a bug. And so they use a bug to get more memory, and everything Windows NT, Windows, that's why OS2 is flat memory model. Macs are flat memory models. Unix is a flat memory model. Everything else is all based on 640K. So when the Windows 2000 came out, they could not get DirectX working in it in time to release it because they were being sued by all these vendors to get their software out. So they said, fine, we'll release it without it. Never added it. It's never been added to Windows 2000. So Windows 2000 becomes the base for server. And so server goes on because server's not playing games. XP comes out. XP has DirectX added into it. It is Windows 2000 with XP added into it. And when you format a drive on Windows 2000, there is a character in the MFT entries that is an asterisk formatted in Windows 2000. When you format it into Windows NT, that character is different and it becomes a number. And so you actually then start having changes in the file system, and you can tell which system's formatted the drive based on an MFT entry. Okay? When you look at a file record, you know there's a 0 after the file. Have you guys looked at file records, MFT file records? There's a 0. The 0 is XP and later. An asterisk, so it'd be file asterisk, is Windows 2000 and earlier. So the whole point I'm trying to make is this. DirectX was the output. Everything else that has an X was named after that based on a derivative that was for the Xbox. That's why it's called an Xbox. It is a slimmed down version of Windows with DirectX on it. That's what it is. Literally is a version of Windows with DirectX hardware, got rid of all the other stuff. So all the X's throughout all of history for Microsoft are all because DirectX is involved somehow. So ExFAT was their file system for the Xbox. The file system that continues on in thumb drives and other stuff that's all based on FAT64 is all ExFAT. Everybody good so far? SDXC. That's what the X is for, is that it's ExFAT, and it came from that derivative. So, now you can get past 32 gigs on an SD card because you use ExFAT. It comes pre-formatted. If it says SDXC on it, it's a requirement for it to be pre-formatted as ExFAT. It is $300,000 for the license. ExFAT is patent encumbered because they didn't want Linux to steal it. They sued TomTom because TomTom made a GPS that included FAT32, and FAT32 is proprietary and owned by Microsoft. They created it. And so even though Linux will use it, it's kind of like chasing, trying to get blood from a stone. They can't get money from it. But ExFAT was patent encumbered, has a whole list of patents, and they decided that we're going to go after anybody in Linux trying to use it. We made it complicated enough, it was going to be very difficult for them to even change the code and make it work the same. Ironically, like 3 months ago, Microsoft said, we are open sourcing ExFAT and we're going to give it away. So we're going to allow Linux to use it because Microsoft is switching to a Linux kernel. Did you guys know this? That they are changing a core and adding the core into Windows 10 in one of the next updates. I don't know when the update's coming, but it will now have a Linux core inside of Windows 10, and you will now be able to spawn off a separate piece of that, and if they left it patent encumbered, they can't release it with ExFAT support themselves, even their own code, because the requirement for anything that talks to Linux is that it's got to be part of the GPL licensing. So if you release any piece of it that uses any other piece that ever existed in GPL, you must also release that piece with the code and the source code as open source in part of the GPL. Right? So they did it so they could have their own. They already got all the money from everybody they're going to get. They got $300,000 in licensing fee from every car manufacturer that exists. Every camera manufacturer. Microsoft and Apple are in bed together. Most of what people don't understand, they think there's a battle going on between the two. There has not been a battle going on between those two since 1997. When Steve Jobs came back, he had to get on his knees and go grovel to Bill Gates and ask him for money because Apple was bankrupt. And Microsoft gave him $150 million. So from that day forward, they had stock and they sold it in 2007 or 2008. And so they share code for many things and they pay licensing fees back and forth to each other. And they had an agreement not to duplicate what each other was doing. So the Windows Phone changed to a Tile phone because they could not look like an Apple phone. Apple got ActiveX, Sync for iPhones to Exchange servers for the corporate world because Apple did not make a mail server. They did make a server. Do you guys remember the X-RAID servers? They killed it at the time they made the agreement with Microsoft, so they did not overlap with the creation of anything that Microsoft made versus what Apple made. So there is no longer an X-RAID server. That's gone. So all of these things all come together. So I know there's a bunch of stories here, but the whole thing was because it evolves in the file systems. And so Microsoft and Apple had an agreement, and in 2011, Apple added all the drivers in to Mac OS for all of the existing stuff, NTFS, FAT32, ExFAT. They added it all back in. XP, who they said they would never update again, they updated with ExFAT. There is an ExFAT driver for XP, and you can add the ExFAT driver back into XP and make it work, because they did not want to have these problems with camera manufacturers saying that we didn't have access to all of our stuff. So this is the story and how this evolved. ExFAT has a whole pile of stuff in it that was meant to be for secure file systems and secure operating systems. Do you know why they don't have those things active? I mean, you've never seen them. It looks like a dumb operating system when you see it. Like your thumb drive doesn't have any of these extra additions on it except that you can store a bigger file on it. Like there's no other addition that you notice as an end user other than I can format it, I'm compatible between the other operating systems, and now I can share a file that's bigger than 4 gigs because that was the largest file size that you could have. It's very similar to NT. And NT, it has security, it has all of the access, everything, it's transaction oriented, but all of this is disabled. All of it's disabled. You know why?
Hardware.
Yep, cameras. The camera itself is off and on. You do not have it on long enough to manage the material. So when they first sold it in 2009, the middle of 2009, they sold it to the SD Card Association for SDXC cards. Camera manufacturers had to have people come back and write drivers that basically controlled inside the camera how you add and delete files to ExFAT because they had no idea how to do it. No, at all. Literally. They still don't. It still gets corrupt. The cards get corrupt if you delete files while you're using them because there's no bad block management. So there's no way for it to know how to manage the file. If you turn it off in the middle of writing, it messes up the file structure while it's doing it because the file structure wasn't meant to be turned off. It was written for a Windows CE phone, so the CE phone was going to be on all the time. Understand? So that's why it's a dumb file system right now. And so the only people using it are thumb drives and cameras and cars. That's it. Nobody else is using it. Who else wants to use it? And you can't boot on it. So that's it. So that's what you're looking at. Now, ExFAT as a whole, RStudios does it fine. There's nothing wrong with RStudios and doing ExFAT. I've never had a problem recovering or losing anything, so I don't need to go into any other software or anything special to do ExFAT. It's very plain. Data is raw again. All your metadata is at the beginning of the drive. You just need to be able to process the file tables. If you can't, what's on the card? Probably not a lot of valuable stuff other than pictures and videos. So if you carve pictures and videos, who cares what the name is most of the time? Right? That's where we are. All right, so next, NTFS. So again, nothing complicated to do on those. It's raw data. It's not a whole lot different than the data that you would get from any other FAT. NTFS. Now this is where things get a little bit more complicated, but it also is beautiful in my mind. So you're talking about 1983, 1984. Somebody's trying to design a file system. What page do we happen to be on? 55, is that what you said? All right, so 54, 55. So here's the thing. The first argument everybody has is there a second copy of the catalog, which is NTFS? And no, there isn't. There is no other MFT entry. Everybody even in forensics for some reason keeps thinking master file table copy is a copy of the data. It is not. It is a pointer. It is 2 sectors big. This entire record is duplicated. This record is 4K. Surprise, surprise, 4K. What happens is, in order for single failure not to happen, they took the first 4 records, including itself, made a copy of it in the middle of the partition. So they go to the end of the partition, they subtract 1 for 0, divide by 2, and write 4K in the middle of the partition. Those are pointers that then the drive can find if something fails, and it will just automatically repair itself. And it's amazing how often NTFS actually repairs itself and never tells you that it did it. I've done all kinds of tests, and you could corrupt things and mess them up, and it'll go back and fix them on the fly. It's really hard to create a corrupt MFT that will mount and actually run in the system boot. It fixes them on the fly, moves the stuff around, and repairs itself while that little graphic is up all the time. Never says anything to you, but it adds it to the journal entry. There's a journal entry that the system keeps track of, that every transaction that happens in the journal. You can go and look at it if you want to piece it apart. It was years. It was like 15 years before we knew how to piece that thing apart and read it. And so now Xways does it on the fly. You now go click on the journal, and the journal will tell you every transaction that happened to every file in text, right there in front of your face. So if you go find the journal running on a drive that you've taken an image of, you click on it, it parses it, and then it'll tell you this file was copied, this file was deleted, this file was added, this file, like every transaction that happens is there. And most forensics guys I know are not even looking at that journal at this point. But you can find out everything that happens on your drive. So these are 4 records. Following this is the string that you would be looking for when you're looking for NTFS. So now, when you're talking about the way file systems are laid out, think about it in clusters and then individual sectors. Because the operating system says, I have 8, and the 8 go together. So if I have 8, then the offset, let's say that the partition wasn't at this location, it was at the next location. It would have to be 8 sectors away. It could not be 1 sector away. Even though I said you can create a partition wherever you want, it has to be on a cluster, so it cannot be on a sector boundary, it's on a cluster boundary. All things are grouped together in 8. Does that make sense to everybody? A file cannot begin in the middle of a cluster. The file begins at the beginning of a cluster, and there's 8 that go together. So I look at the first one, and the first one will tell me what the file is if there's a header there. If it's not that one, I don't have to look at every sector. I just go to the next 8th one. 8 away every time. Does this make sense? Good, Tim? All right, so the whole point being this, I would be looking for this string. I would find where it is. That's the beginning of my partition. The beginning of my partition is here, and then from there on, that will be a partition. So I can literally make one or rebuild one by hand if I had to. All your software is looking for that. So your software is literally crawling through it. Now, NTFS has records. It is a structure, and then inside that structure, there are records. These 2 pages are the records. So there's a total of 16. Some are reserved. So we don't need to worry about those. In data recovery, here's the important ones. So Tim, if you're writing it down, here's what you want to know. The MFT is the most important of all the records that there exists. The MFT is not a real, these are not real things. These are binary data, and when the operating system comes up, it groups the data together and gives it a fake name. And the fake name starts with $1. You know why it starts with $1? You know why Microsoft starts everything with dollars? Microsoft loves money. That's the only answer we can come up with. So every single thing that's supposed to be an operating system file, it is supposed to start with $1. It did not happen in Windows XP, but later in Vista, they renamed the remainder of the things that weren't, which is the recycle bin and the user's recycle bin and things like that all got renamed. So they begin with $R and $I, and the recycle bin has $1 now in front of it as well. So all the files that are associated with the file system now have $1 in front of them. The operating system parses them out and shows them to you as a logical item, but they're really not. They're really just a group of individual sectors that it gathered together based on size. So $MFT is an item that we can copy while the drive is running. It is not technically a real thing. The mirror is the 4K. It tells you there it's 4K, blah, 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 a duplicate of the first 4 records. We do not need that. We only need this, MFT. We need the volume information if we care about the name and the serial number of the volume and the dirty bit. Otherwise, we don't need it at all. It doesn't help us in recovery. We don't need the attributes. We do need the root folder because the root folder does always have files in it. So we will get the root folder, MFT, and the rest of the stuff we can ignore. The bitmap, what does the bitmap do? What does a bitmap tell you? Not a picture, but kind of like a picture. If you were to take an overhead view of your hard drive and think of it as a picture, it says these are allocated, these are unallocated. So it's clusters that are allocated. So sets of 8 sectors together are allocated if there's a 1 in the location. The only thing that you really need to use a bitmap for is to figure out, do I have data there or do I not have data there? If I have data, I want it. If I don't want the data, it's unallocated, ignore it. So for your purposes, forensics people want it, but you don't need it. Because you're only going to get the files back that exist, not the files that deleted. Right? Long time gone. The boot sector we do not need. The bad cluster is an amazing story, but it's unimportant. Other than the fact that hard drives were designed prior to IDE, there was MFM and RLL drives. They did not have a way of managing the hard drive, so the bad cluster was to manage MFM and RLL files. Occasionally a file goes bad and it makes its way in there and the cluster gets marked bad, and what you will normally see at the beginning of a file record is FILE, which coincidentally all fit in hex. FILE is what you see for a file, and then an index record, and then following that is bad, B-A-A-D. It'll actually be a bad cluster, and it'll put B-A-A-D in the beginning of the record. And so you'll see that from time to time, but it's not really important for us in data recovery because our drives manage themselves. It should never be used. $secure is a file that contains the security structure so that Bob cannot access Alice files. Somebody else cannot access somebody else's files. That is in our way. And so we're going to ignore that for the moment. And then the rest of these records you don't need to worry about at the moment for data recovery. The extend record will work only if MFT records are intact. So let's talk about this for a minute, and I'm going to give you a real world example. Protected folders. Bob can't access Alice files, right? You get a data recovery in. Let's say, Tim, you get a data recovery. You put it on the deep spar. You image it. It came from a client who either has a domain, which would be like a server or a corporate network, or it came from a user at home or a small company that when you set up the user, it said, do you want to make your files private? And you click a button, and it says yes. What actually happens is it runs through the hard drive, and it finds all the records associated with that person, and it creates what's called a combination of a RID and a SID number together. And the RID and the SID numbers are these strings that calculate a numeric value that's specific to your user. and your user can only access that data if the key included your RID and your SID number. And if you had a domain, then you have to belong to the domain and be able to log into the domain, or you cannot get access to those files. So this makes sense to everybody. So this is all done back in 1984, 1985 when they created OS2 to go through this process for security, and it separated everybody out from that standpoint. So here's what happens in real life. You have a folder. Now you can see on this drive, I'm doing a data recovery for a company. In this case, it was actually an ice cream shop. And the ice cream shop had set up their computers, and when somebody clicked, hey, I want to make my folders private, he said yes. And so it reset up this RID and the SID number, just like it would if it was on a domain. They're the identical process, okay? So that key is now created for Snow Cowboy. So now, if you, as a user, are not part of their subset of their domain or their machine, and you're not logged into it, when you try to access Snow Cowboy, like I try to click on Snow Cowboy's folders on Windows on my machine, it would reject me. It would not let me have access because there is security on the drive, and NTFS mounted it when I plugged it into my Windows machine, and it kept me from seeing his files and folders. Does this make sense to everybody? So, in this world, I am restricted from seeing or working on Snow Cowboy's files till I belong to this. I cannot log in as him either, because this is a second hard drive on my machine. I'm not booting on his drive. I don't have a way to recreate his data directory structure, active directory structure, to get into his system. Do you understand what I mean so far? So, here's what happens a lot of times. I see this all the time. Same thing that happens. So Geek Squad comes in, takes a hard drive out of the CEO's computer, walks over and plugs it into his computer. He replaces the hard drive on the CEO's computer. Then he goes to copy the data over to the CEO's computer. So they do this. Everybody I see does this. They go to the root of the C drive, they click, and they go Control A. And then they go right click, and they say copy, and then they go over to wherever the drive is, and they paste. Right? You see that? You know what I'm talking about? Let's say Snow Cowboy's folder is down inside of one of these. So his user folder is down inside one of these. What error do I get when it finally gets to Snow Cowboy's directory in the middle of copying all of these files? What error will I get? Permission denied is one option. What else? Anybody?
User not found.
User not found. I don't think you get that, but okay. Because user not found, you still knows the directory, so it'll see Snow Cowboy, but I don't have access to Snow Cowboy, so it doesn't care if it's a user. It thinks it's a folder. At that point in time, I don't have Active Directory active, so it can't tell me if it's a user. Anybody else? Any other guesses? So here's the thing. When it gets to the Snow Cowboy directory, you get no error. 0 errors at all. It will just say, Tim, you don't have access to this, and so I'm sorry, but we're ignoring it, and we will just keep on going. And it will never pop up a box. It will never tell you that you do not have access to it. It only explicitly tells you you don't have access to it when you try to go to it. It assumes that you are Bob, and you are trying to access Sally's files. And you don't have access, as Bob, to go see Sally's files. So therefore, we'll skip it. What if it is the trash can? The trash can for Sally does not belong to Bob. So if you're trying to copy folders, it'll just give you the folders you have access to and ignore the files you do not have access to. You get my point? So yes, the user doesn't exist, but you don't get access to it at all because you're not logged in as any user that has access to those users. So you don't have access. As an administrator, you have a higher access, and your administrator SID and RID numbers then will be able to access those because you have an escalated permissions. But you do not have that in this case. So when you get to the CEO's folder who came from a domain, the Geek Squad guy did not copy it. Does that make sense? It just ignores it and keeps on going. The same thing for a dozen other directories. Inside of the rest of your system, you have these. System information files. The system information and system volume information is all the stuff in XP, in this case, would be the drivers that are there for redundancy, volume stuff that's for snapshots, for backups, called VSS, admin is what it's called. And so there's a whole bunch of things in there that you don't get access to. You don't get access to the recycle bin for other people. You get yours, you don't get theirs. So if there's, in this case, maybe, and I've unhid all these directories, so there may be other users in there, and you don't have access to them by default. So there is a whole pile of those kind of things you don't have access to that you can't get. And it would just skip them, and you wouldn't read them at all. So now what happens is the Geek Squad guys copy off all the files. They think they have everything. They put it on the CEO's machine, and then they erase that drive or whatever else happens to that drive, or they don't have access or whatever. But the CEO, you know what he's missing? His whole user folder. He doesn't have his PST file, he doesn't have his mail, he doesn't have his Word documents, doesn't have anything. So if they're doing an upgrade, sometimes they do it in place and they overwrite the drive. And then it's too late because they didn't know they didn't have it, right? So in these particular instances, it becomes a real problem because you don't have access to that content and it's gone. And here's the other thing. You know how they decide that they have all the data on the drive? You all do this. I know you do it. Every one of you is guilty of doing this. Control A, right click, properties. How much is on this drive? Every one of you have done this, right? Is this number right? It cannot be right. It is impossible for this number to be right because you will never have access to everything on the drive because you at least don't have system volume information if you're formatted with NTFS. You do not have it. You don't have access to this at all. Now maybe it's not important. Maybe your video files are all accessed by you, so it's not a big deal. And so who cares about system volume information? I hope you skip it because I don't want it. But this isn't correct. But watch this. Here's the thing. Everybody had the ability to do this, but you don't think about it. Go to C drive. Right click on the C drive and properties. How long did that take? It didn't take an hour for it to count all my files because when you're counting all the files, it's actually crawling through MFT entries, adding all the MFT entries up, and then giving you a calculation. And it may take a while. It could take a really long time on a big hard drive, right? But this one, how long did that take? Split second. Why? What is that? Where did that data come from? Come on. Where did it come from? There's only one place it can come from. What is it?
Hard drive?
Custom drive.
Where is this data?
MFT.
Keep going. What other records are in the MFT? In the NTFS volume? The bitmap. The bitmap is allocated and unallocated. It's instantaneous. It knows from one file every cluster that's used and every cluster that's not used. So crawling through your own operating system and looking at it yourself, you have to kind of start imagine where is this stuff coming from as you're going through this process, because this is your bitmap. This is actual, true, used, and free space that the MFT entries believe is free space. Because when they are freed by the MFT, then they go to the bitmap and update the bitmap and say, you can now use this space. So this is a picture of the bitmap as you're going through the process. Does this make sense to everybody? So it is unallocated space. This is how the drive knows to find free space that it can use. And that's instantaneous, and that's the true story, because if you have access to the bitmap and the MFT entries, you can do anything you want to the computer. If you are malware or ransomware, and this is why ransomware can do what it does. It doesn't matter if Bob has access to Sally's stuff, because in order for Bob to have access to Sally's stuff, what must Sally's stuff be able to present to them? If I am a user and I am in Sally's folder, where is Sally's folder's data? Where is Sally's folder's records about her data? in the MFT entry, and the key for the security for the MFT is tied to the security descriptor file in the NTFS structure from the MFT. So it has to access the MFT, look for security. Does Bob have access to it? Well, if you can do that, your ransomware can too. It can access it directly and automatically take over all the files and just encrypt Sally's folders. And then Sally has no idea how to get to it. Because if you can see the MFT and the records, you can control everything. And this was how Citrix was always a problem. Like, you could bypass Citrix issues, pop into somebody else's folders by going through the MFT entries. You could just pop out of it. So they've done a lot of work to try to separate those things out and isolate them and sandbox them so that you can't do that anymore. But it still happens. It still is a problem. They announced one of them just a couple days ago with code execution. You can remotely, without being a user, execute all the code on the entire system. So anyway, I'm just going through the process of what you're looking at as far as tables. So this is a bitmap. These are MFT records. So these are all the records for an MFT. So an MFT, and I'll pull it up as a quick example. I know some of you have seen this. Let's see if I have. Nope, we're going to live right here. So, all right. On this hard drive, I have files. This is my actual C hard drive on this machine. So it's the actual laptop hard drive. So every file in the operating system that I am seeing, this would be what I normally see in my directory structure. This is the actual normal Explorer directories that I would be looking at. This is Xways or WinHex that I'm looking at, same thing. So this is the MFT record in hex, not the content of that file specifically. It just happens to be the same in this case. So I have a file, and it's called long.txt. And that file has a file record associated with that. So it has all the date and time attributes, all the content, and then you'll see the beginning of it. This record right here is the beginning of this record. So file and 0 tells me I'm formatted on XP and not Windows 2000. Windows 2000 will be an asterisk. And so I can actually tell, and then before that there will be another record, and they're done in pairs. So if you look, there's one sector that's empty, and then there'll be a sector with another file record. So when you find the first record, it will begin with file, and then from file then on, each one of these pieces is the date and time. See the color coding? It's in binary. I have to highlight things and use the decoder to figure them all out, but those are the dates and times that are being displayed here. All the stuff about this file is only in two sectors. Two sectors tracks all the metadata for this file together. Good? So here's what happens. If I have a file and I have been writing it to the drive and the drive crashes while I'm writing the file, this is a transaction-oriented file system. Same thing as journaling. It's an identical thing to journaling, but it may be a different process. Microsoft doesn't like to use journaling because it's a Unix, Linux version. You guys know that Microsoft wrote one of the first Unix clones that ever existed too. It was Xenix was the name of it. They wrote it in 1986 before they even had Windows out or anything, and they sold it to Santa Clara Operations, and you now know it as SCO. So SCO Unix was written by Microsoft and was one of the first Unix PC derivatives that existed, which so surprising. Microsoft had such a hate and dislike for everything. But anyway, that's how evolution happens. So I need to make sure you understand this one piece. In a normal file, where there is file here, this is the attributes. So this is the name of the file in their file record. So it starts with the record in this little tiny database, MFT, $MFT, and it's tracking this file. So I have a file, I have dates and times and things that are in here. Now there's one more than most people ever see. There's a file date and time. there is an actual date and time associated with the rename of the name of the file. If you rename a file, there is another piece that is not displayed in those columns. The only forensic software that shows it is Access Data, and it's only because he spent 3 days in my lab and I showed him how it works, and that I could fool forensic software by renaming a file and overlapping it with a real file, and you couldn't tell the difference, but I manually manipulated a file kind of like Touch does on a Linux system. And so they wrote a special column for it, and it'll highlight it red if somebody's been messing with the files. So, so here's the thing. Inside the file, there's these tracking items and there's attributes. In the attributes, if they add up to less than 1024, because there's two 512 sectors, and if it's less than 1024, it'll store the data in here. In this case, the ms-dos.system is too big, and so this file does not exist in here. This is the file name. The file name itself is stored in here in Unicode. So there's characters in here for Unicode, so they can translate it to other file name, to other dialects. And then you have slack space, like junk, that would sit there. So there is a spot where there's a delimiter for the name of the file, and then you have blank space and junk. You see this random thing down here that's a quote mark? As you watch, you'll see, now the attributes of this file are still less than 2 sectors, and so it just happens to be that it did not need the rest of the space to store this. So this blank space right here is there for, mostly for, a long file name. So MS-DOS is a very short file name, so it did not need that much space. But I can have 255 characters. So 255 characters would cause it to overflow into the next sector for the file name. Does this make sense to everybody? And I'll show you why it's important. When you get down past that, and even though there's blank space, you'll notice there is again another quote mark in that position right there. And that's a blank sector, right? So these things right here are very important to the file system and transaction-oriented. It's actually a complete genius thing that they did. But here's what happens. I'm going through the file system, I write a file. The file crashes, the system crashes before the file is complete. In the process, I need a way to track that I was creating a new file, I created a new MFT entry, something bad happened, and the old file still exists. I delete that last. So I'm replacing a file with another file, system crashes. Did it complete? Yes or no? And if it did not complete, then get rid of the one that I was writing when the system crashed and leave the original there. That's the idea behind a transaction or a journal operating system. Everybody good? Okay. Now, which is the same thing SQL does. Same thing, SQL backs it off. All right, so now I'm going to show you the difference between a file that is a non-resident file, so the MS-DOS file does not exist here, only the name exists here, and the file exists and is stored out there in raw data. So in data somewhere, I'll find an EXE that'll be a raw file. EXEs all start with the character MZ. So EXEs and sys, they start with MZ because that's the characters that were the initials of the guy who wrote the EXE executable for Microsoft in the first place. And I don't remember his full name, but it's MZ as his characters as his initials. And that's the beginning of every EXE file will be what you're searching for. So here's a long file name. Now the long file name, the attributes of the long file name overlap. So now you'll see here's dates and times, and then you'll see long, here's the short file name. There's always a short file name, and then there is a long file name. And you see long, and it keeps on going into the second sector. And then this is the end of that sector where the boundary is, and then the next file starts. Everybody get where I'm at right now? All right, so here's what check disk and scan disk does. When you reboot for crashing or whatever happens, and the flag kicks on and it says, hey scan disk, I had a problem with my hard drive and I crashed. I need you to check me out, make sure I'm okay, and that all the transactions completed and finished. Here's what it really does. I don't know if you'll ever find this anywhere. I don't know if it's documented anywhere. I've never been able to find it. So in this long, where the file starts, date and time, there is an item that's right here that is called, there's an array, There's 2 characters for the beginning of the position of the array, and I just happen to know where it's at. And then there is 4 placeholders for the array right here. There are 4 pairs of placeholders, or 2. There's 4 of them altogether. There's 2 pairs. Everybody understand what I mean so far? So that's an array. Every time I write something that changes this file, a date and time or something else changes, it increments or decrements this character here. So this item right here is a sequence number, and it adds 1 or subtracts 1. So if I'm making a change, I make a change to that number first. So I make an entry, I make a change, and that increments. So the next one's going to be OE. So it would increase, okay? Then I go away, I do all my work, I copy the file, I replace the file, and I come back, and then the last thing I do is I do something called Fixup bytes. So this OD right here, right next to this, is a 6FOO. What character does that make? What does 6FOO make? What is that? Huh? So lowercase o, right? As I scroll down, you'll see at the end of 512 bytes, the very end, you'll see the counter. You see the counter right here? So here's 512 bytes where this dashed line is. You see the ODOO? What is that? What is it called? What did I tell you it was a minute ago? It's a fix-up byte. And this is the sequence number of the fix-up byte. So you'll notice I did not misspell the word. If you look at the word up here that says long, 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 it is not misspelled. There is no O missing. But if you look here where it's stored, you'll see long, long, and then O missing. Long, 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 long. So the name overlaps into the next sector. That fix-up byte is now a sequence number. So they picked up the character. They wrote the name there. They literally write the name there. They pick up those 2 sectors. They move them to the array location right here and write those 2 there. Then pick this up and write that there. So now, at the very end of the transaction, if I have completed the transaction, it updates the sequence number and the fix-up byte. If I did not complete the transaction, then that one would not say OD. It would be whatever it was before it was OD. It would have been OC because it would have been decremented by 1. Does that make sense? So the record did not complete copying. So I would have been copying a file, and the file never finished, the system crashed, and so OD never got written there. OC would still be there. So CheckDisk's entire process is to look at, does that last 512 bytes match OC, OC? If it was OC, OD, nope, sorry, wrong, delete the file. That's all it does. The second process does it for folders. Exactly the same way. The only difference is instead of a file as the header, you'll actually have an index. So index will do the exact same thing. It'll just delete the whole folder and not just the file. Do you understand what I mean? There is only destruction. There is no repair. It only destroyed what you had. And if you did not make a copy of it, and that was a critical file, you've lost all the data. It clears out the rest of the sector. When that sector is now bad, it will mark it bad, and it will now clear out the rest of the MFT entry, and it will not use it anymore. And you have lost all the files that had those things that were wrong. So if I have a piece of malware, and it just went around and changed 512 byte extensions on every single one of those, it would erase all my files. As soon as CheckDisk ran, now they do somehow have a list of priorities. You cannot do that to the Windows subfolder. The Windows folder, I've tried to kill it and I can't. So now here's the other thing. This 512 bytes is not only updated here, it is updated at the end of the next 512 bytes. See? OD. So it does it for both positions in the 512 bytes. So it updates the Fixup byte with the sequence number, and it did copy this, but these characters were 00, 0. So 00, 0 is right here. Right there is the 6F.